Hasn't the dream of VR always been to put on a headset and move freely for a fully immersive virtual world? Unfortunately, the current reality often looks very different. Before you start playing, you have to tediously tidy up your room. And then, once you're inside the game, you are stuck in this invisible cage, which often breaks immersion and forces a lot of games to use a natural artificial locomotion. For this to change, VR games need to understand the player's real environment. That is why we are choosing Build-in SDK to make this as accessible as possible for VR developers. We call this auto-adaptive mixed reality because the game content automatically adapts to the user's environment. This creates a new level of immersion because your room becomes part of the experience. To show you how our SDK actually works, let's jump into Unity. What you're seeing here is a room scan. This one comes from our own scanner, which ships with the SDK, but Meta and Pico scans work just as well. For us, a room scan is ultimately just a JSON file. Once you've got a scan, you feed it into an adaptive processor. That's the heart of the SDK, and it contains a list of adaptive objects and is responsible for mapping them onto the scanned environment. If I hit process, you can see how quickly it generates a result. The whole process is highly optimized and fast enough to run at runtime without any issues. Now that we've covered the basics, let's take a look at how you can create your own adaptive content. Here we have a table asset. To make it adaptive, simply right-click it, select Convert to Adaptive Object, and adjust the bounding box if necessary. Then you can assign it to the adaptive processor. From there, you can define building rules. Building rules consist of two parts, constraints and DNAs. Constraints determine where an object is allowed to be placed. For our table, for example, we might only want it to appear on surfaces that are actually classified as table, and we could also require a minimum size or specific aspect ratio, whatever makes sense for your asset. DNAs, on the other hand, determine how an object adapts once a valid placement has been found. For example, simply scaling a table usually doesn't work quite well because it loses its intended shape. That's where components like the slice mesh DNA come in. It lets you define exactly which parts of a model may be stretched and which parts should remain unchanged. Another good example is the fill volume DNA. Instead of stretching in a single mesh, it fills a target volume using predefined assets. This is especially useful for irregular shapes that aren't directly covered by your asset library. In the adaptive simulation view we built, you can quickly check how your objects behave at different dimensions. And you get a preview of how all your adaptive objects look together when you drop them onto sample room scans, without ever putting the headset on. That's the basic workflow, but there's a lot more under the hood. We ship with over 50 constraints and DNAs, giving a huge amount of flexibility when adapting content to real-world spaces. We've also built small tools like a shadow baker, which automatically generates simple baked shadows after placement. Since dynamically placed content can't rely on traditional light map baking, we had to come up with a different solution. And once you've created a solid set of building rules, changing themes becomes incredibly fast. In many cases, you can simply swap out prefab references and transform your medieval castle into a snowy landscape, a sci-fi facility, or whatever setting your game calls for. The logic stays the same. We've already built a few small games with this tech that you can play on the Meta Store, some of them for free. So if you want to see how the SDK actually feels in practice, go check them out. And if you think this could be useful for your own VR game, feel free to apply for the beta version of our SDK. And please let us know what you think about what we have built so far.